Okay, welcome. Today is another day, good morning, and welcome to this beautiful time we're going to have together. And I believe at the end of the class or this lesson or this video, if you can watch it to the end, you have the reason to tell me thank you. If you are doing mathematics, computer science, and or engineering, of course, they require some of this method and technique to help you in doing series of things in matrices. The most times you come across matrices other than a square matrix or a 3 by 3 matrix, sorry. So, and you may be looking for a way to find the inverse of such matrices. Um, it becomes very difficult using the normal matrix technique that we know, like finding the determinant, going through, finding the cofactor matrix and the adjoint before you can get the inverse. It becomes very difficult when you meet something like 4 by 4 matrix, 5 by 5 matrix, 6 by 6 matrix. So what do we do then to solve this problem? We come across the uh, method we call the Gauss-Jordan elimination method of finding the inverse of a matrix. Now, how does this really look like? Now, imagine you have an identity matrix and you have a matrix A. You have a matrix A and an identity matrix. Now, you carry out some row operation. You carry out some row operation uh, in these matrices. The row operation as if you want to find an elementary matrix. Now, by the time you carry out some certain rules operations on these two matrices, you find out that at the end of the time, this side that you have the real matrix A will become an identity matrix. And then this part where you have the identity matrix will turn to something else. Let's call that matrix C. Now, this matrix C is automatically the inverse of the matrix A. And that's what I'm going to show you today. That's what I'm going to show you today. And in this class, it's going to be practically, I don't want to talk much. So it's going to be completely practical on example so that they will not miss up. I will try as much as possible to do up to 2 examples. I will use the 2 by 2 matrix to carry out these operations. And then I will also use a 3 by 3 matrix. If you need an extra work, maybe you have a 4 by 4, you have a challenge, please you can drop it in my comment section so that we know what I can do. I can maybe give it to you handy, or I can do another video for you or because of you under that with 4 by 4. But I believe you may not have that problem because by the time we are done with this, you should be able to deal with any other of the metrics of the problem of this kind. So let's go straight to the business. I want to find, let me give examples. Find the inverse of matrix A, which is equals to, I want to start with a 2 by 2, 2 minus 3, 3, and 4. Using Gauss-Jordan, using sorry, I misused the letter of such brave man. Gauss-Jordan method. This guy was really a brave chairman. Okay. So before we start it, please don't fail to comment. Don't fail to subscribe to this channel if you've not, because like I said, every time something crazy is going to be coming up on this channel, and trust me, is going to be amazing, and I'm going to make sure I do something very, very good in this very channel. And I'm going to try as much as possible to make it the best for you. Okay, let's start. I'd like to use this dressing method. Say solution. Oh, sorry. Can't really use this to get my straight line. So I will show solution to that. So, like I explained earlier, I say you will have a matrix A. And since we are dealing with a 2 by 2 matrices, you will also have identity matrix that have the same order with the matrix A. So the matrix A we have in this problem is 2 minus 3 and 3 and 4. Okay. So this 2 by 2 matrix. So the identity matrix of this is going to be like this. Okay. So the Gauss-Jordan technique is simple. I'm going to explain it very well. It's simply you transforming this side to become an identity matrix, and this side becoming, once this side become identity matrix, this side will definitely become something else, will become a new matrix, and that new matrix is your inverse. So all you need to do is to carry out some row operations on this matrix and the same operation on this matrix. And by the time you do that, you end up with that result that I'm trying to tell you. So let's start. The first thing I will do here is I'm going to deal with this row 1. You see, I want to make this row 1 here to look like this. So my interest is on this first entry, A11. So row 1 will now become 1 divided by 2 times row 1. Okay. So you see, let me use here to do a kind of illustration. So for example, the entry here, the first entry is 2. So 1 all over 2 times 2 equals to 1. So I have 1 there. And then minus 3 over 2. Sorry. Just be so fast to get the result at once. So this will be 1 over 2 times minus 3. That would be equals minus 3 over 2. So the next time I want to write this row 1, the new row 1 I have right now is 2 divided by 2, that's 1. And then we'll have minus 3 over 2. Okay. I will repeat the row 2 because I didn't touch that row 2. So then 4. All right. So here will become half 1 over 2. Here, 1 over 2 times 0 is still going to be 0. So this is going to be 0. This is going to be 1. All right. So the next time, I'm going to deal with my row 2, just like I dealt with row 1. So row 2 equals to row 2. Just want to do some stupid thing there. Yeah. Just looking at the table. Row 2 minus 3 times row 1. Why do I do that? I'm going to explain that to you. Times, come on, 3 times row 1. All right. So why am I doing that? I just look at the row here. I know that if I multiply 3 to this place will become 3. And that by the time I do 3 minus 3, like row 2 minus 3 times row 1, that I'll have 0 here. Don't forget, I'm looking at having an identity matrix here. So then, my interest is to transform this place from 3 to 0. So I know that if I multiply 3 here and subtract this other row 2 from this row 1, yes, and or row 1 from the row 2, that will give me 0. So by the time I do that, I will have a new matrix. I will have a new matrix like this. So you have, let me write it here. So the row 1 that is going to be 3. So that is row 1. So that is going to be 3 minus, because already the first entry there is 3, minus 3 times 1. So that is 3 minus 3, that is 0. So I'm going to write that place 0. I'll write 3 minus 3 over 2. Then, and this place, the second one is going to be 4 minus 3 times minus 3 over 2. So that will be 4 plus, there is a minus sign there, 9 over 2. So that will give me 8 minus 9 all over 2, and that is minus 1 over 2. So we have minus 1 over 2. Oh, sorry. I miscalculate that place. I have a plus sign there. A plus sign there. So that is 8 plus, sorry about that. So that is going to be plus, because I said that place is plus. So that would be 8 plus 9 divided by 2. That will give me 17 over 2. Yeah, now it's correct. All right, so we have 17 over 2. So, coming to this other side, I'll write the first row, half. All right, here 0. Here will become, uh, here will become, uh, let's look at it. Here will become, this is row 2 here is 0 minus 3 times 1 over 2, or 3 times 1 over 2. So that would be minus 3 over 2. So we have minus 3 over 2, minus 3 over 2. And here will become row 2, that is 1, minus 0, and that's still going to be 0. I've seen that. Okay. So 1 minus 0, because 3 times 0 is still going to be 0. So 1 minus 0 is going to be 1. So we have 1 there. Okay. So let me clean that up, because I will need that space for some good work done. All right. Okay. So we are almost done. So the next thing I will do is now be looking at the work. I want to make this place 0, and I want to make this place 1. It's easy to make this place 1 than to make this place 0. So I'll first make this place 1. So I will still deal with my row 2. I will say row 2 now will become uh 2 over will become 2 over 17. That is the inverse of this number here, times row 2. And if I do that, I will have the row 1 will repeat itself. We have 1 minus 3 over 2. 2 over 17 times 0 is 0. 2 over 17. 2 over 17 times 17 over 2 is 1. So that place is 1 now. So coming here, I repeat the row 1 as 1 over 2, 0. So 2 over 17. 2 over 17 times, look at that place. So we have 2 over 17 times minus 3 over 2. 2 here will cancel 2 here. So I have minus 3 over 17. So minus 3 over 17 minus 3 over 17 minus 3 over 17. So I want that place is not really bold. Minus 3 over 17. I have half 0 minus 3 over 17. Then 2 over 17 times 1 give me 2 over 17. Here, 2 over 17. Okay. All right. So, the next operation I will have here is, now you see, here is 1. Here is 1. So the only problem we have right now is here. So I will say that row 1 now, I want to deal with row 1. Row 1 finally will become that row 1 plus, know that if I use 3 over 2, that will eliminate this place to 1. So it will become 3 over 2, 3 over 2 times row 2. So the operation will go thus. Okay. So that will become, the matrix we have there will be row 1, 1 plus 3 over 2 times 0 is still 3 over 2. I mean, it's still 0. So 1 plus 0 is 1. And it's 1. I don't want to rush in this class. I really want you to get it. So the whole thing is in your mind. You can do it as much as the way you like. So, and here, this minus 3 over 2, look at that place. The second entry there will be minus 3 over 2 because that is the row 2 entry or element. So plus, here will be 3 over 2 times the entry in row 2 is 1. So this is minus 3 over 2 plus 3 over 2, and that is 0. So we have 0. We have 0 there. Now, we go ahead and write it. This is the result. And now bring down the row 2. Now do the same thing to here. We don't touch the row 2. So we will write the row 2 and carry out the operation in row 1. So the row 1 here is going to be, let me strike it down. The row 1, the first entry there is going to be row 1, that's 1 over 2 and plus 3 over 2 times row 2. So row 2 there is minus 3 over 17. And that gives us 1 over 2 minus 9 over 34. Okay. So the LCM of 2 and 34 is 17. So that will give us 17 as a fraction. Or let's take it to the next page. So that will give us 17 on the denominator. Sorry, I'm going to take that up. So I can clean that up because I want to deal with your. All right. So let's also check. I mean, you have 1/2 minus what we have there. That is our 9/34. 9/34. All right. So that gives us 17 on the denominator. Uh, that, and then we have, sorry, a lot of shit there. Have to be careful, take this very easy. Sorry. So we have 34 as the LCM, and it goes to the 17 minus 8. Okay. So that will give us check out there what we have. So what we have there is almost done. Almost done. I think I've messed up there. Please let me take it to the next page because I'm struggling with that small scale. So let me take it there to the next page. All right. So, all right. So we have what we got there was we got our 1, we got our 0, we got our 0, we got a 1 for the matrix there. And for this other part, that's where okay. We have enough space here now. So let's do that again. So if we have this, we said that the row 1, now how we got that was that row 1 becomes row 1. Row 1 becomes row 1 plus 3/2 row 2. Like row 1 becomes row 1 plus 3/2 times row 2. Yeah, I needed that space, seriously. All right, so we got it for the left matrices. So let's see what we get there. So that will give us the element we had initially in the first row is let's go check that out. Is half. So row 1 there will be 1/2 plus 3/2 times the row 2 entry of half is minus 3/17. So we have minus 3/17. All right. So that will give us 1, 2, 9. Just change that place to minus. So let's say minus 9/2 times 17 is 32. You have 32, 34. So now we carry out the operation there. The LCM is 34. So we have okay. All right. So we have that 34 goes to 2, that's 17. 17 times this is 17. Minus 9. So we have minus 9. Okay. So what do we have then? What we have there is 8. That's minus 8. I mean 8/34. So 2 can come here, 4. 2 can come here, 17. So we have 4/17. I really needed that space. Okay, so we have 4/17. 4/17 for the first entry. So, and we are dealing with row 1. So let's complete the row 1 because already we got the row 2. So I'm not going to touch the row 2. So, and then for the second entry, we have 0 plus 3/2 times row 2. Row 2 of that 0 is 2/17. 2/17. Where did I get that from? Look at it here. You have 2/17 there. So, and that will give us, this is 6. But before the 2 can cancel 2, we have 3/17. 3/17. All right. So now we repeat the row 2 because we didn't touch the row 2, which is minus 3/17, 2/17. So we have minus 3/17 and 2/17. All right. So now we see we've gotten our, can clean this up. You've gotten our identity matrix, which you can see the left-hand side of the board. And we've also gotten our new matrix. You can call that elementary matrix if you like, but I don't like, no, it's not elementary matrix. So I think this is the elementary matrix because we carry out some row operation from the, remember, elementary matrix, that matrix we obtained from carrying out some row operations on the identity matrix. So we've gotten this particular elementary matrix is known as the inverse of of the matrix A. So can say A inverse is equals to 4, 3, minus 3, and 2 by, there is a common denominator that all of them have. That means 1/17. So 1/17 can then be regarded as the determinant of this matrix. Okay, I'm going to explain why I'm saying so very, very soon. Why? Because we know, I can write this as 1/17. So the inverse of that matrix A is now equals to that. Why I'm saying so, if you were to find the inverse using the adjoint principles in the normal matrix operation, the inverse would have been the determinant of A times the adjoint. So we can say that this is the adjoint. Can just say this is the adjoint matrix right now. So the combination of the adjoint by the scalar 1/17 now form the inverse. So it's not bad. You can still allow it to be inside, or you can just bring the stuff outside, but we've gotten the result we wanted. You can apply this to a 3/3 matrix, and then you will still have the same results. Okay, right. I promised to do it with a 3/3 matrix. So I'm going to do it in a very quick way. So if A is equals to the matrix 1 minus 2, 1 minus 2, let's say 0, 1, and minus 3 and 4, and then 1, you have a matrix like that. Right. So let's find the inverse. Let's find inverse. I'm going to be a little bit very, very fast. Okay. So just like we did before, I will say I'm gonna put that there in something like what we did before earlier on. So and carry out the operation with 1 minus 2, 1 minus 2, 0, 1 minus 3, 4, and 1. Then 1, 0, 0, 0, 1, 0, 0, 0, 1. So we have these two matrices. Okay. 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 So we right now going to carry operation with the row 2, and the row 2 equals to, I'm going to combine them row 2 plus 2 row 1. I'm also going to carry out matrix in row 1. I got out of row operation in row 1. I mean row 3, sorry. That is row 3 equals row 2, row 3, okay, equals to row 3 minus row 1. So by the time I do that, I have, you can try that yourself, you see. You have 1, 0, 0. You have 2 minus 4. You have minus 3 then. All right, you have minus 3. And we have minus 2 here. You have 2. Yeah, that's what that. All right. So down here, row 1, when we didn't touch row 1, so row 1 remain row 1. So row 2 will become 2, 1, and 0. And then the row 3 will come minus 1 and 0 and 1. All right. So we're still going to carry out the operation again. No, this time I will say that I'm interested with the row 1 because I want this place to be 1. So row 2, sorry. Row 2 will now become row 2 plus row 3 plus row 3. So by so doing, you will have the new matrix as 1, 1. Let's see that. Let's see that. Let's see that. Yeah. That's into this. Okay. Okay. 1 minus 2 minus 3. Okay. 0 minus 1. Yeah, that's true. Okay. 0. And then we have 0. We have 3. We have 2. And down here you will have 1, 0. Okay. You will have, I want to demarcate this from, okay, you have 1, 0, 0. You have 1, 1, 1. You will have minus 1, 0, and 1. Okay. Then the next one I'm going to do, let me keep those matrices shorter. So the next one I'm going to do there is, I'm going to have a new matrix like this. Let me do like this. Okay. So I'm going to carry out row matrix again with row 1. Row 1 will become row 1 minus 2 row 2. Then row 2 will become minus row 2. And then row 3 will become row, let me check what I have there. It will come row 3 plus 3 row 2. Okay. So this will give us give us okay. This will give us 1, 0, minus 3, and 0, 1, and 0, then, and minus 1, or minus 1 then. Yeah, minus 1. You have 0 and 3 and 2. Then to this other side, you will have 1, 0, 0, 1, 1, 1. I'm not messing up things there. 1, 1, 1. Then minus 1, 0, and 1. Let me confirm something. 2. Okay, I'm just repeating this place here. All right. All right. So by the time we carry out this operation, here the new matrix formed from these operations is 1, 0, minus 3, 0, 1, 0, then 0, 0, 2, of course. Then to the identity side, you will have minus 1, minus 2, minus 2. You will have minus 1, minus 1, minus 1. You will have 2, 3, and 4. Okay, okay. So, also, what is wrong with that thing? Also, here, I'm looking at this matrix. If I can, it's very easy. This is the problem right now. So I want to make this place 1. So the only thing I can do there is that row 3 equals to 1 over 2 row 3. So 1 over 2 row 3. So row 3 equals to 1 over 2 row 3. So by the time I do that, I will have 1, 0, minus 3, 0, 1, 0, 0, 0, 1. Okay. All right. So this side will become minus 1, minus 2, minus 2, minus 1, minus 1, minus 1. Then here will become 1 and 3 over 2 and then 2. Okay. Then we also carried out operation. Let's go back there a little. Let me write the operation. So now row 1 is the problem. I want to make this place 0. So I will say row 1 now becomes row, you can say row 1, you can say row 1 plus 3 row 3. Check out, that's what it is. So if you do that, you multiply 3 by row 3 and add it to row 1, everything will change to what you will have right now. So you will have the main matrix become 1, 0, 0, 0, 1, 0, 0, 0, 1. And then the other side matrix will become 2, minus 1, minus 1. Oh, sorry, that's not true. I'm copying the wrong side. All right. So that side will become 2, 5 over 2, 4, minus 1, minus 1, minus 1, then 1, and then 3 over 2, and then 2. Okay. Okay. So we see, we've gotten the identity matrix here, and we've gotten another matrix. Let's call this matrix C. And the C equals to the A inverse already. We've gotten our inverse matrix. So therefore, you can come here and conclude that A inverse is equals to, if you want to write it the way we normally write it in the other form, that's a 1 over 2 because we have a denominator of 2 here. So if you factor out 2 here, become 4 because it was not, like that. Move it inside, it become 2. Here will become 5. Here will become 8. Here will become minus 2 across, minus 2, minus 2, minus 2, because everything there were minus 1. Okay, so this will become 2, and this will become 3, and this will become 4. So that becomes our inverse matrix. So inverse matrix is this one, or you can write it in this form by condensing and removing out our determinant. So that is what I have to show you today. Remember, in summary, is that to carry out the operation from the main matrix and carry out the same operation on the identity matrix. Now, the main matrix will now become the identity matrix after your operation. Your intention, your mission is to make sure that the main matrix is becoming or has become identity matrix, while the other one will turn to a new matrix, which is not identity, it's not necessarily becoming. So by the time you do that, that new matrix obtained become your inverse matrix. This can be also applied to any order of matrix. It will help you to find matrix of any order because is going to make a whole lot of sense. Yeah, this principle also help us to find a rank of a matrix when the matrix is not a 2 by 2. Okay, so that is what I have to show us today. Please make sure you subscribe to the channel. I told you I'm going to drop some good stuff. I'm going to take time to explain it, and make sure you always follow the class to the end. Follow the class to the end. Makes sense to do that. All right. Thank you very much. Make sure you subscribe, refer a friend to visit my channel. It's just a new channel. The channel is 3 weeks old, I think. All right. So the comment, if you have it, I don't mind. If you tell me I'm wrong, I will really go back to my stuff and check. But I doubt you said that. Please like and subscribe to the channel. Comment if you have any, and it will make the the video and the content to keep on improving day by day. Thank you, and thank you.